All right, good morning. It is Monday, March 23rd, 10:06 a.m., and we are going to do a little fraction review lesson today. So all you really need to do here is watch the video, and then at the end, there will be one thing for you to submit and one little challenge for you at the end. So we're going to go ahead and get right into it here. First thing I have for you is this very colorful chart that just gives you a visual of really what fractions are. Okay? And I know we've talked about this a lot in class, and this should be a review, but it's always good to go back over things and make sure that we're solid on some of the fundamental concepts that we should have down as fifth graders. So at the top here, all right, you've got your one whole, and then every layer down that we go, so every color is a new fraction. So you have halves, thirds, fourths, fifths, all the way down through twelfths, and you'll notice as the denominators get bigger, the pieces get smaller. And that makes sense because the more pieces we're splitting something into, the smaller the pieces are going to be. So if you think about a pie, if you're splitting that pie with just one other person, you're each going to get half a pie, and you're going to get quite a bit and probably get a bellyache later. If you add a third person and split that same pie into now 3 pieces instead of 2, you're going to get a smaller piece of the pie because you're splitting it more ways. And that would be true all the way down if you were sharing it with 12 total people. You guys would split that same pie into much smaller pieces than what you did when it was just 2 of you splitting it into halves. So this is just, again, a visual model for you. The bigger the denominator gets, the smaller the pieces in terms of size get when we're talking about splitting up a whole. Okay, so here we have a fraction 2/3, and what that really means is we have 2 out of 3 parts that make up a whole, and then again we have our visual over here. So if you think about our pie, if you split that pie into thirds, and I have 2 of the 3 thirds, we could say that as I have 2/3 of the pie, and then somebody else has the last third, or it's been eaten, or it went somewhere. We don't know where it got to. 2/3 is a proper fraction. Okay, a proper fraction is when you have less than the whole as your numerator. So we have 2 out of 3. So 2/3 is a proper fraction because we have less than one whole represented by 2/3 here. If a fraction was improper, like for example, if we had 3 halves, that would be like saying, okay, we have a whole, but then we have this extra half also. We have 3 halves, which is going to be more than a whole. Okay, if we simplify that, we get 1 and 1/2. So just some terminology, some vocab there for you. 2/3 being a proper fraction, and then 3 halves being an improper fraction. Also, you'll notice proper fractions, the top number, the numerator, is always going to be smaller than the denominator if it's a proper fraction. Impropers is the opposite. The numerator on top will be bigger than the denominator. All right, so some more terminology, some more vocab things. Again, just shoring up these ideas that we've all heard, we've talked about, but I want to make sure that we have down as we go through this week of lessons, because this week's going to be all about fractions, and we're going to progress through fractions and fraction operations, building all the way up to eventually, probably next week though, adding and subtracting, multiplying and dividing mixed numbers, as well as just fractions. So fractions are a part of a whole. So it represents some part of a whole. We don't have all of it. So that's why we call it a fraction. It's a piece, and we have different size pieces depending on how many things we split them into. That kind of references back to this diagram. Okay, the more pieces we have, the smaller each of those pieces will actually be in terms of true size. We said this already, but the top number is called the numerator. There we go. Top number is called the numerator, and this is representing how many pieces we have. Okay, if we're talking about 2/3, top number being 2, that means we have 2 out of 3 pieces of the whole. The bottom number then is the denominator. And I'm going to be a little slow writing here. I'm doing it with my mouse, which is kind of tricky, but we'll make it work. So the bottom number is the denominator, and this is how many pieces are in a whole, or how many pieces make up a whole. So for example, if we go back to 2/3, okay, I have 2 of the 3 pieces it makes to have a whole. 4/5. Okay, now 5 pieces make up a whole. That doesn't mean that the whole got bigger or smaller. Okay, we're still talking about the same pie, the same size. We're just saying that we're splitting it into more pieces now, splitting it into 5 pieces instead of 3 pieces. Okay. Also, if you think about 1/2, okay, halves, you know, is splitting something into 2 groups. Okay, splitting it in half. I have a half, you have a half. Together we have a whole. Okay, so I have 1 of the 2 pieces it takes to make a whole. All right, so just some things there that we need to make sure we have down. Right here, okay, and I know you can't actually do this, but go ahead and pause the video here for a second and just jot down on a piece of scrap paper or whatever you have handy where each of these fractions over here would go on our Venn diagram. So if they are less than a half, they're going to go over here. If they're equal to a half, they're going to go in here. And if they're greater than a half, they're going to go here. So when you're ready, pause the video and then come back when you have those sorted. Okay, so 1/3, all right? The way to check whether or not a fraction is more or less than a half, there's a couple ways to do it. One way to think about it is to look at the denominator and say, hey, what would half of that be? And if your numerator is more than half of your denominator, your fraction is going to be greater than a half. So for this one, I'm thinking, okay, half of 3. Well, 3 is an odd number, so it's going to be, my half of 3 is actually going to be a decimal, and so I could say that half of 3 is 1.5. Well, 1 is less than that, so that means that 1/3 is less than a half. Okay, and if we come back here, okay, we can check that, right? Here's 1/3 in orange, here's 1/2, and a half is clearly bigger than a third. Now, for this one, for 3/4 here, okay, the other way to think about this would be to say, okay, what would half of 4 be? Well, half of 4 is 2, 3 is greater than 2, so that means that 3/4 is greater than a half. And if we come here, okay, we can check that again, right? 3/4 would be all of this right here in yellow, and that is bigger than a half. Okay, these 3/4 put together make 3/4, and that's bigger than a half. So that one goes there. 4/8. Now that one, if you ask yourself, okay, what's half of 8? Well, half of 8 is 4, which tells us that this is equivalent or equal to 1/2. 2 4s make up 8. 7/12 are going to be greater than a half. 3/8 is less than a half. 6/12, well, half of 12 is 6, so that one must be equal to a half. And then we have this 9/2 left. Okay, hopefully you noticed that this was an improper. Okay, and anytime we have an improper, that automatically tells us that it's greater than a whole, and if a fraction is greater than a whole, it's definitely going to be greater than a half. So that one's going to go in that category as well. Okay, so one other thing that we need to talk about, and we've talked about it in class a lot before, so again, this should be review. Hopefully this is nothing new to you, but that is a common denominator. Okay, and in order to add or subtract fractions, we always need a common denominator. I'm going to use blue now, just to switch things up. Common denominator. Okay, and then right here I have listed 3 ways that we can find a common denominator of 2 fractions. So for example, here we have 4/6 and 2/3, Yes, I know 4/6 is not in simplest form. That's fine. These are the two fractions we have. So the first one here is check if factors. Okay, and what that means is to find a common denominator, what we're really trying to do is turn both of the denominators into one number that's the same. So if you think about it, 3 goes into 6 evenly, right? In other words, 6 is a multiple of 3. So if we think about how many 3's would fit into 6, the answer to that would be 2. So we can turn 3 into 6 just by multiplying it by 2. And that is good for us because that gives us a common denominator. So we didn't even have to change this fraction. So if you're looking for factors, and this really should be, I said factors, it's multiples. But if you think about, like, we didn't have to change 4/6 at all, that's great. Now down here, 2/3, okay, if we multiply the bottom by 2, in order to keep it fair and keep the top and the bottom equivalent to what they started as, we have to multiply the top by 2 also. Okay, and what we'll discover is that actually we have two fractions that were equivalent. 4/6 just was not simplified. Okay, but that'll get us a common denominator. The other way, and I would add too that this will, if you check for check the factors and multiples, that's going to get you the smallest common denominator possible, assuming you don't miss one, which sometimes happens, and that's okay. The second way here is the QCD, okay, right here. That stands for quick common denominator. And all you're going to do here is you're going to take the two denominators and multiply them by each other. So 6 times 3, and down here we're going to do 3 times 6 to get us a common denominator of 18. Now you'll notice this is not the same common denominator that we just found. There is more than one common denominator. This one is not the smallest one, but that's okay. It's still a common denominator which would allow us to add or subtract our fractions as we needed to. Always, 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 if you do something to the bottom of a fraction, you have to do the same thing to the top. So because I multiplied 6 by 3, I have to multiply 4 by 3, okay, to get me an equivalent fraction to 4/6 with a denominator of 18. Same thing down here, multiply 3 times 6, need to multiply 2 by 6. Okay, and again, we see that these fractions are equivalent both to each other and to what we started with. Okay. The last strategy we have here, it's very similar to the first one. It's just it's a few more steps. I like this one because it has a visual aspect to it. But what it is just taking the two denominators, so 6 and 3, okay, and writing out the multiples of each. So 6, 12, 18, 24, etc. Okay, you don't need to write out a ton. You just need to have enough that you're going to find some overlap. Here I'd have 3, 6, 9, 12. Okay, and you're going to see some numbers that are in both lists. We want the smallest one. So for our purposes, that would be the 6 right here and right here. Okay, this is another way to find the smallest common denominator. Okay, so 6 is the smallest multiple that both of these numbers share. So if we turn both of those denominators into 6, we're going to have our common denominator and our smallest common denominator. Now you'll notice, okay, 6 is the first multiple of 6. So this would be like multiplying by 1. 6 is the second multiple of 3. This would be like multiplying by 2. So over here, we're going to multiply 3 times 2. The top by 2 also, and then 6 by 1, and the top by 1 also, which recognize that will not change the fraction at all. Multiplying by 1 doesn't change the number. And we again have our similar fractions with a common denominator of 6. All right. Now I want you to practice one, okay? Pause the video here and find the least common denominator for the two fractions listed below. Okay, so hopefully you had your common denominator found, and whichever strategy you used is fine. I'm just going to show the quick common denominator, which is multiplying the two denominators by each other. So we're going to multiply 8 times 3, which means we multiply the top of that fraction by 3. And down here, 3 times 8, and the top of that fraction by 8. Okay, so up here we get 15 over our denominator of 24. And down here we get 16 over our denominator of 24. Okay, so this is handy because now we could add these fractions just as they're written. It's also helpful because it actually shows us that 2/3 is ever so slightly bigger than 6/8, or excuse me, than 5/8, which can be really hard to tell when we have different denominators. But when we have the same denominator, okay, we know all the pieces are the same size now, so all we have to do is compare the top numbers, 15 and 16, and we can see that this one is the bigger of the two. That can be helpful when comparing fractions. All right, so that's our lesson for today. For your submission, I want you to comment the denominator that you found for 5/8 and 2/3 on this post. It'll be a private comment, so I'll be the only one that sees it. So yeah, go ahead and do that. And then today's outdoor challenge, because with being at home, it's often easy to stay inside and get cooped up. But go outside, enjoy the weather. Hopefully it'll be a little sunnier here. It's kind of cloudy right now, but at least it's warm. So go outside and do your best cartwheel. And let me know how that goes. All right, I will see you all tomorrow.